Today, I will take you through the exciting future of steelmaking, where sustainability meets innovation. Traditional steel production is one of the largest contributor to global CO2 emission, accounting for nearly 8%. This means nearly more than 2 tons of carbon dioxide are emitted for every ton of steel made using coal-based blast furnaces. With the global steel demand expected to rise by 6% by 2030, decarbonizing steel production is not just favorable but critical. Green steel making, especially through hydrogen, offers the potential to cut emission by up to 90%, aligning with global climate goals. Let's explore how this technology works and why it matters. Now, this is the slide which shows that what is hydrogen blast furnace technology. Hydrogen blast furnaces represent a transformative leap in steelmaking technology. Instead of burning coal, these furnaces use hydrogen gas to reduce iron ore. The chemical reaction between hydrogen and iron ore produces water vapor instead of carbon dioxide, drastically reducing emissions. This method can reduce emission to less than zero point 0.4 ton per ton of steel compared to the around 2 tons from traditional methods. Often paired with the direct reduction iron plants and electric arc furnaces, this technology is poised to redefine the steel industry. Now, coming to this slide about who is leading and where. Currently, Europe leads the race in green steel development with projects like Hybrid in Sweden paving the way. Major steel producers such as SSAB and China's HBIS group are investing heavily, along with innovative startups like S2 Green Steel. The European Union alone has committed nearly more than 95 billion euros by 2027 to support green steel and hydrogen projects. Besides Europe, countries in the Middle East and the US are building hydrogen ready steelmaking infrastructure, signing a global shift. Now, coming to this slide, which is about a why hydrogen advantages over conventional steelmaking. What makes hydrogen the game changer? Simply put it, produces only water when it reacts with iron ore, unlike coal, which produces large amount of CO2. Hydrogen driven processes also operate at lower temperatures, reducing overall energy demands. This flexibility allows using recycled scrap steel and enable easier operational controls. Significantly, every kilogram of hydrogen used eliminates approximately 25 kg of CO2 emissions, making it a highly efficient carbon abatement solution. Now, coming to this slide, which is about when is hydrogen steel making expected to scale? Hydrogen steel making is still its nascent stages, but is progressing rapidly. Several pilot and demonstration plants are either operational or scheduled to come online between 25 and 2030. A key challenge lies in producing green hydrogen at scale and at affordable cost. Currently, between 4 to $8 per kilogram, industry experts target a range of $2 to $3 per kilogram to make hydrogen steel economically viable. The next decade will be critical for transitioning from natural gas blend to 100% hydrogen. Now, coming to this slide about where the challenge is. Despite its promise, challenges remain. First, green hydrogen production must ramp up from needs to industrial volumes. Infrastructure for hydrogen storage, transport, and distribution is lacking in many reasons. Current cost remains high compared to industry targets. Furthermore, the steel sector faces investment risk due to the scale and novelty of technology. Policy support, subsidies, and collaborative industrial effort will be vital to overcoming these hurdles. Now, coming to the slide which is highlighting how to accelerate adoption. So, how do we fast track the hydrogen revolution in steel? Developing integrated hydrogen supply chain near a steel plant is paramount. Operational innovation and digital optimization can maximize hydrogen usage efficiently. Governments play a crucial role by offering incentive and subsidies to reduce financial risk for steel producers. Finally, collaboration among steel manufacturers, renewable energy suppliers, and technology innovators will shape a suitable steel ecosystem. Now, future outlook and conclusion. In conclusion, hydrogen blast furnace technology heralds a new era for carbon neutral steel production. It provides a viable path to slash steel industry emissions, aligning with global net zero emission. Investing in research, infrastructure, and policy support is essential now to unlock this technology full potential. The steel sector's transformation will be indispensable for a sustainable future, expected to be mainstream by 2040 to 2050.